Good morning. Myself Dr. U.B. Malkhandale, Assistant Professor in Priyadarshini College of Engineering. Here I am in Electrical Measurement and Instrumentation Laboratory for the demonstration of Kelvin's bridge. So first of all, we'll look a detailed idea about the bridge. What is bridge? Bridge is nothing but which consists of 4 arms. Arm 1, Arm 2, Arm 3 and Arm 4. So for construction of any bridge we need 4 arms. So Kelvin bridge comes under the category of DC bridge. There are 2 types of bridge, DC and AC bridge. We are going to perform the experiment on DC bridge. DC bridge means we will give the DC supply, and for detector here we are using the galvanometer as a detector for null detection. So let us move towards the circuit connections. So this Kelvin bridge trainer kit, which consists of 4 arms. The first arm is R1. There are 3 possible connections are given for 3 different readings. Similarly for R3, an unknown resistance arm is Rx1, Rx2 and Rx3. And one more arm is R2. This is variable potentiometer. With the help of this potentiometer will be used to make the null detection of this bridge, or we can balance the bridge. So let us move for the connections. So first of all, do the connections. Here the numbers are given. Connect point number 1 to point number 2 so that R1 will come in the circuit. In the similar way, you can connect point number 6 with the point number 2, that is arm number 2 is completed, which will come in the circuit. In the similar way, point number 10 and 11, this also come in the circuit, that is Rx1, this is the unknown resistance, and R2 resistance is already connected in the circuit. As the name is Kelvin's bridge trainer, here R1 and R3, which is called as the ratio arms. Now moving towards the galvanometer connection, you can see the galvanometer is shown on the kit. The galvanometer connections, that is point number 17 is connected to point number 19, that is positive point, and point number 18 is connected to the point number 20. So galvanometer connections are over. Now we have done with all the connections. Moving towards the performance of the experiment. First of all, switch on the supply. Supply is switched on. You can see that the galvanometer is showing that deflection is towards the left hand side. Now to making the bridge balance, we need to adjust the variable resistance R2 pot so that the galvanometer will show the null deflection. Here you can observe that galvanometer will show the null deflection. Okay. So we can only find it. Yes. So this indicates that when there is no current is flowing through the galvanometer, then only bridge is balanced. As you know, the balance equation of bridge, the product of opposite arms must be equal. So in this case, the product of opposite arms must be R1 into Rx1 is equal to R3 into R2. So this is the balance equation. Now you switch on the supply. Measure the resistance with the help of multimeter for this variable pot R2. So for measuring the resistance, you should switch off the supply and measure the resistance with the help of multimeter. You can observe the pot reading. Okay. So by using this R2 reading, now put this reading in the formula. From balance equation, you can calculate that Rx1 is equal to R3 by R2 into R1. Put the value of R2 and calculate the unknown resistance Rx1. In the similar way, this step is repeated for Rx2, Rx3, and the average of these 3 unknown readings will give you the value for unknown resistance Kelvin bridge, and Kelvin bridge is used for measurement of low resistance. Keep this in mind. So your values should be between 0 to 1. So this is the complete performance of this experiment. Thank you.